All right. Hello, hello, hello. Today we're going to be talking about the acceleration equations. So I want to do a real quick review on the equations for velocity. Hopefully you're pretty familiar with these, having already done the first half. So these red equations are the equations that we use when we're doing basic velocity calculations. This is what we've been calling the velocity equation, or the red equations. Okay, where v is the speed or velocity, s is the distance, and t is time. Okay, and that's pretty much it. What we're doing today is dealing with the acceleration equation. Now, technically, the acceleration equation is, well, much like this one here is the acceleration is the change in velocity over time. Now, in this context, that change in doesn't really matter. It's ultimately not super important because we always assume that your initial displacement or your initial distance traveled is zero. So it doesn't really matter. But when we're talking about acceleration, you're very rarely starting or stopping from rest. If you're driving on the highway and you hit your gas pedal to speed up, you have an initial speed and a final speed. So we have to actually account for that in the acceleration equation. We can't just ignore it like we do in the velocity equation. So that's going to be kind of the main thing here, is you're going to have to not only identify your acceleration, your velocity, and your time in your questions, you have to distinguish between the initial velocity and the final velocity, which isn't that hard if you're paying attention to the context of the question. Okay, I'm traveling at 15 meters per second. I hit my brake. How fast am I going? Well, 15 meters per second was the initial velocity because it's how fast you were going before you hit your brake. So yeah. Now, I've got 3 practice problems we're going to go through. Once we've done that, you guys are kind of on your own. There's another 8 practice problems on the worksheet 7.3b. So yeah, let's get started. We'll start with practice B here. A obviously was the one that was on the first worksheet. It was on the first set of notes. So I am traveling steadily at 8.3 meters per second. I accelerate at 5.37 meters per second squared for 5.72 seconds. What is my new velocity? Okay, so in this case, we are being asked to find what? Well, for some of you, you've already figured it out. Okay, but let's start at the beginning and work our way across. Okay. I am traveling steadily at 8.3 meters per second. Okay, I'm going to pause this and fix my pen because I turned my TV off over the weekend. All right, much better. Okay, I am traveling steadily at 8.3 meters per second. Meters per second. That is a velocity or speed. Okay, so this has to be v. Which v? Some of you may have figured that out already. Some of you may not. But we're going to say, hey, this is a v. Okay, I accelerate at 5.37 meters per second. Well, we have seconds squared. We have 2 ways here that we can tell that this has to be an acceleration. The first is that I accelerate at. Therefore, this must be the acceleration. It's not always going to say I accelerate at, though. So how can you tell when it doesn't say, hey, this is my acceleration? Well, you have to use your units. This is why we had you doing that assignment where it's like, hey, what are the units of this? What are the units of this? What are the units of this? Because that 2 right there tells you this has to be an acceleration. Because only acceleration has meters per second squared. This means acceleration. So this has to be our acceleration. Okay, likewise, 5.72 seconds. This has to be our time. What is my new velocity. Well, new, that's the one that's there at the end. So this means it's asking us to find new velocity. That has to be Vf. Therefore, this, if you had not already determined it, had to be Vi. So, we are looking for Vf. Now that begs the question, which one of our three equations do we want? I'm going to pause this and write them on the board. Accidentally double-click the button, so there might be a weird flash there. All right. So these are our three versions of our acceleration equation. Now, the first and obvious issue is none of these are solved for Vf. Okay, and this is going to be a problem every time you are finding a velocity. Reality of the situation is there are about 5 or 6 different versions of this equation, and we're not going to give them all to you. There is going to be some minimal requirement from you to do a little bit of equation manipulation here. However, while none of these is solved for Vf specifically, there is one that is solved for V. And so we can use that equation to figure out what we're after. So the middle equation here is solved for Vf minus Vi. Well, Vf is the thing that we actually want. So if we move Vi to the other side before we start plugging stuff in, plus Vi, then this is the equation that we want. Vf is equal to At plus Vi, or Vi plus At. It's the same thing. Just make sure you multiply before you add. Or, if it makes more sense to you, you can calculate At and then add Vi to it. But either way, you should get the same thing. Now, we have no unit conversions that have to be done here because everything already matches. We have meters and meters, seconds, seconds, and seconds. So we can just go in. We can just plug and chug. So, our equation is Vf equals At plus Vi. Therefore, A times T is going to be 5.37 times 5.72 plus 8.30. Now, you have to multiply before you add. Order of operations, PEMDAS, if that makes you feel better. Okay, we need to multiply these two numbers. I don't have a calculator in my hand, so I'm going to go get a calculator, and I'll unpause this when I get back. All right, so we plug this into the calculator. When we multiply these, we get 30 point, that's going to 3 digits, so that's going to be 30.7. We add 8.30 to that, and that's going to be 39.0. So that's our answer. But what is it? Well, it's velocity. We know that has to be Vf because that's what we were trying to find. What are the units on that velocity, though? Well, the units that come out have to match the units that go in. So if we put in meters and seconds, then we should be getting out meters and seconds. So this is going to be meters per second, and that, unless I made any stupid mistakes, that should be our answer. Now, I am going to step off the screen here. I want you to take a crack at practice C on your own. Now, when I say on your own, identify the variables first. Identify the variables, then we'll check that, and then you can actually work it. Figure out what equation you need and actually solve it. But check your variables. Make sure you're identifying them correctly before you do a ton of work. Yeah. So pause this. Going once, going twice. Okay. I am now assuming you have paused it. You have a list of variables that have been identified. So I slow from 82.0 miles per hour to 65 miles per hour with an acceleration of negative 15,000 miles per hour squared. How many seconds? did it take me to slow down? Well, miles per hour, this has to be a velocity. Miles per hour again, this is the other velocity. So I slow from this to that. So this has to be VI, this has to be VF. That does not look like enough. That'll work. Okay, with an acceleration of negative 15,000 miles per hour squared. Well, that has to be our A. And then how many seconds is T, which is what we are trying to find. Okay, now, before you start doing your calculations, I trust that you can figure out which equation you need. That's pretty easy. Before you start doing your calculations, I want to say this negative sign, really important. That doesn't look like an arrow. Hey, that negative sign is really important. If you don't include that in your calculations, you will not get the right answer. That negative sign means I'm slowing down. Okay, and you have to know how to enter that on your calculator. So I'm going to show you the button you have to hit to put that specific negative sign in. When you subtract, you use this button right here. That's the minus for subtraction. However, when you're trying to put in a negative number, you have to use this minus sign. Okay, the one at the bottom of the calculator. If you're using a Casio, good luck. But this is how you do it on a TI. Okay, so now, pause this, work it out, get the answer, then unpause it, and we'll check and see if you did it right. All right, I am now going to move on under the assumption that you have done this calculation. You have an answer that you are looking at. So, we obviously, if we're looking for T, we need to use the equation that's solved for T. So, T is equal to VF minus VI over A. Am I still on the screen? Yes, okay. So VF minus VI, that's going to be 82 minus 65. That is 17. Yeah. So that's 17.0 divided by negative 15,000. Okay. Some of you are going, hey, this is going to be a really, really weird number. Yes, we'll get to that in a second. Okay, so 17 divided by negative 15. Wait, no, I did that wrong. Did you catch my mistake? This is a mistake you have to keep an eye out for. This is a very easy mistake to make. My answer is not 17, it's negative 17. Because it's VF, which is small, minus VI, which is big. So it's actually 65 minus 82, which gives us negative 17, which cancels out our negative sign, so it's going to give us a positive time. Okay, very common mistake. Make sure you don't do that. Okay, so 17 divided by 15,000. That is going to give us 0.00113. What are the units? The units are hours. This is how many hours you're going to be decelerating. What does it ask for? It asks for seconds. So you do have to do a little bit of a conversion here. But those of you who have been paying attention know that all you have to do here is multiply by 3,600. So times 3600. That means that that number in hours is going to be 4.08 seconds. Okay, now, I forgot about this. Yes, your time is sometimes going to require seconds because this number in hours means absolutely nothing. 0.000113 hours? How long is that? That means nothing to anyone. 4 seconds. That makes sense. I know what that means. That's an obvious conversion that you're going to have to do. Okay, you're probably going to have to do this a lot when you're looking for time. And I would recommend doing the conversion at the end, not trying to convert all of these, because you'd have to do, these two wouldn't be too bad, but you'd have to do exponential conversion here because it's hours squared. So you could do all this before, but you'd have to do 3 conversion tables to convert everything to hours. Or you can just, convert everything from hours to seconds. Or you just leave it in hours, get an answer in hours, and convert it to seconds. This is way easier. Okay. Now, there is one more practice problem, so I'm going to pause this, pull it up. And same thing. I want you to go through and identify the variables. And here in a second, I will go through and tell you what they are. All right, at this point, I am assuming you have already identified your variables, and this is supposed to be your feel-good confirmation. You did it right. So, first off, what was my velocity? Stop. That's obvious. What is that? Was. What was my velocity? What was the velocity before something happened? VI. This has to be VI. VI is the thing we're trying to find. So this is another one where we're looking for velocity. We're going to have to use that second equation. After accelerating at negative 3.75 meters per second squared, plus it says accelerating, so this has to be A, for 10.75 s, or seconds, so that is t. I am now traveling at 15.27 meters per second, so this is a v, obviously, and if it's now, not before, then this has to be the f. It's the after. Okay? So, I'm going to have you do your own equation manipulation, write down what you think that is, and then I will show you on the board how to do that properly. Okay, I'm about to go over that. All right, cool. Now, this equation, we need to use VF minus VI equals AT. We want this. So we need to move VF away. Well, VF is currently positive, therefore we have to subtract it. So we are going to subtract VF from both sides. So negative VI equals AT minus VF. Now, this presents an obvious issue. That's not a real convenient equation. We really want this side to be positive. So we can just multiply the whole equation by negative 1. Or divide by negative 1, same thing, no matter what you've heard it called. Basically, we're just going to flip the sign of everything in the equation. Now, for the sake of your own sanity, when you have a negative plus a positive, swapping these can make your life a little easier. So then our actual equation that we are going to be using is VI equals VF, that's not an F, VF minus AT. Okay, because negative AT plus VF is the same as VF plus negative AT. They're the same thing. It doesn't matter what order you do with them. You still have to do the multiplication first, but that's not going to be too big of an issue. So now we can plug in our numbers. So we have VF, so VI is equal to 15.27 minus, we need to do this multiplication first, so I'm going to put parenthesis, negative 3.75 times 10.75. Yeah, 1.75. Okay. I'm going to use a calculator for that. So that's going to give us 3.75. That's divided by 1 times 10.75. Make sure I entered it right. Yes, okay. So now we want 15.27 minus negative 40.3. Those negatives cancel. This is why it's really important and why swapping your variables can actually make your life a little easier. So we add these two and we get 55.57, which needs rounded to 3 sig figs. So our answer is going to be 55.4 meters per second. And that's it. Now, there are 8 practice problems on worksheet B, 7.3b. that is linked in Canvas. You should also have gotten a paper copy. If you don't have one yet, we're about to give it out. If you are virtual, if you're doing this from home, you'll have to pull that up on Canvas. The worksheet should already be linked. The notes of the part, I'm worried might not be there. Though if the video is there, the notes should be there. So that is it for this video. Have a wonderful day, and I will see y'all next time.